Hi everyone. So today we're going to be going over what is a variable. So either this is the first time you're ever going over a variable or you needed reassurance about what a variable is. So first we're going to be going over a formal definition for a variable, but first I just wanted to remind everyone that there are timestamps available in the description and throughout the video. Okay, so first, a variable. When we think of a variable, we usually think of x or y, but in actuality, a variable can be any variation of letter or symbol. So we have an alphabet, um, pi, etc. So the formal definition for a variable is any letter or symbol that represents a value or acts as a placeholder. So this is going to be the formal definition for our variable. All right. So as I mentioned, when we usually think of a variable, we usually think of x. So let's say x equals a value, and a value can be any quantitative number. So let's say 3. All right. X can also be 9. Not in the same realm, of course, but as you can see, x can be any quantitative value, and x will be the variable to represent that value. Okay, so let's devise an example. Okay, so here we have 5x equals 10. But before we go about solving this equation, I want to make a distinction. It is appropriate to write 5x equals 10 in the following terms. 5 dot x equals 10, or 5 times, let's take x to be a different variable, m, since we're using the x multiplication, equals 10. Okay, so writing these three are all appropriate to represent a particular equation. And in this instance, we have 5x equals 10. And what all of these are saying is that 5 times a value equals 10. Okay, now to solve the problem, 5x equals 10. So our first rule is that we want to always isolate our variable. We want to isolate the variable that we want. So then we have 5x equals 10, and when we want to isolate the x, we have to divide by 5 from both sides to get our x alone. And we know that 10 over 5 equals 2. So in this instance, x is equal to 2. And we can confirm this by plugging back into our original equation. 5 times 2 equals 10. And if this equation holds true, then x equals 2. Let's look at another example. 20 minus 10x equals 120. Now we have more steps involved when we want to isolate our x. But now we have addition and subtraction part right here, and then we have our multiplication part right here. So first, what we want to do is subtract our 20 to both sides. This is another rule that we want to remember. Okay, we're subtracting the 20 from both sides. So then we're going to get negative 10x is equal to 100. And then finally, we get that x is equal to 100 over negative, don't forget the negative sign, 10. So then x is equal to negative 10. And again, we can plug into our original equation just to confirm that this answer is correct. A negative times a negative is a positive, so we get 20 plus 100 is equal to 120, and 20 plus 100 is 120, so 120 equals 120. So that confirms that x is equal to negative 10. For our final example, we're going to look at x over 3 minus 24 over 3 equals negative 1. So first, what we want to do is add or subtract our like terms. And in this instance, we have negative 24 over 3 that we want to move over to the right side of the equal sign because the negative 1 is also a quantitative value. So we have x over 3 minus 24 over 3, and we want to add 24 over 3 to both sides. So that we can isolate our x. And we know that when we add and subtract fractions, we need to have common denominators. So in this instance, we're going to have negative 3 over 3 plus 24 over 3. Which is going to be x over 3 is equal to 21 over 3. And then we want to multiply 3 to both sides. And then we get that x is equal to 21.